Hypothesis testing. The research topic. Research question. The fundamental initiator of the research. It is the one that should be answered by first collecting data, and there will be variability in that data. The research project sets out to answer the research question. Okay. A hypothesis. A hypothesis is a supposition or proposed explanation, a statement or sentence, if you will, made on the basis of limited evidence as a starting point for further investigation. In other words, it is a possible answer to the research question with little or no empirical evidence. The theory, methods, and practice of testing hypothesis by comparing it with the null hypothesis. Okay, so that's hypothesis testing. The null hypothesis is only rejected if its probability falls below a predetermined significance level, in which case the hypothesis being tested is said to have that level of significance. Okay. Now, in this course, we'll be taking three approaches, or two main ones, and you have a third one. We can call it a third one. The critical value or classical approach. That's one approach for hypothesis testing. There's another approach called the p-value approach. And there's another approach called the p-value approach using Excel or SPSS. Okay, so that's how we'll be conducting hypothesis testing in this course. Critical or classical approach, the p-value approach, and then the p-value approach using Excel or SPSS. But it's Excel we'll be using. SPSS is another, statistical program. So now it says the theory, methods, or practice of testing hypothesis by comparing it with the null hypothesis. That's a reiteration of what is hypothesis testing. The theory or methods and practice of testing a hypothesis. And we know a hypothesis is a supposition, a possible answer. So you have to test that answer. Okay, never forget the process of statistics. We start in a hypothesis, we collect the data, organize, represent, analyze the data to make informed decision in order to prove or disprove the hypothesis. So you have to test to see whether the hypothesis is on the right track, okay, based on what the data is saying, and then to see if we have answered the research question properly or not. So now we're going into informed decision making with assignment D. All right. Assignment A is collecting, organizing, and representing data. Assignment B is analyzing data, numerically analyzing data. Assignment C and D is informed decision making. Okay, so we're making the round trip with the assignments with regards to a research project. Okay, so the hypothesis test being studied, or as we say, a hypothesis is a supposition or proposed explanation made on the basis of limited evidence as a starting point for further investigation. So you start the research by making a hypothesis, and you conduct the research to prove or disprove the hypothesis. So the hypothesis test being studied, because there are a lot of hypothesis tests. If you Google it, there are different types of hypothesis tests. But in this course, we are going to study 4 of them. The z-test for mean, and here the symbol for mean is the mu, not x with a bar, is mu. That's another symbol for mean. Testing the claim made by someone regarding the mean of a variable. So the name speaks for itself, t-test for mean. Then you have what you call chi-square test or goodness of fit. Chi-square now is a Greek symbol. Here it is. Some say chi, and normally say chi. I think it is the chi sound in Greek. So if we have to spell a word in English that's starting with chu, like cheer or church, we will use ch. But I think that chu sound in Greek, there's only one symbol for it, and here it is. Or probably it's the chi or chai, okay? But it's the chu sound, the letter for the chu sound. I'm not too sure why the statistician used that symbol to name this type of hypothesis. Okay, they have their reasons why, but that's just a symbol for that type of hypothesis. Very popular type of hypothesis, chi-square. So the z-test and the chi-square. Now we have three different chi-squares we're going to study here. Chi-square test for variation, chi-square test for randomness, and chi-square test for independence. So 4 of them in all for this course. The z-test for mean, chi-square test with a goodness of fit test, so chi-square test for variation, chi-square test for randomness, chi-square test for independence. Bear in mind, a hypothesis test is to test a hypothesis. A hypothesis is a supposition, a proposed explanation. Okay, so whenever a research is conducted, one of the main objectives, the final aim or goal, is to test that hypothesis. And when you reach here, is to see whether or not that hypothesis, which is a supposed answer to the research question, because the research question initiated the research in the first place. Okay. So these are the 4 hypothesis tests we will be studying in this topic, in this course. And here are the steps for the critical value or the classical approach. 8 steps. I will just name them because I'm looking at the time. State a pair of hypotheses. And here's the explanation. We'll go into it later down. All of this is for the z-test for mean, and all of this is for the chi-square. So all that information there is regards to the hypothesis for the z-test for mean. And this is the information for the hypothesis for the variation, randomness, and independence. Okay, because you must start a hypothesis test with a pair of hypotheses, a pair of statements. Always bear in mind, hypothesis is just a fancy word for a sentence, a statement. The next step, you have to sketch a curve, a distribution curve. Third step, there's called a critical region that has to be shaded. Okay, we'll talk about that. Fourth, you have to place a critical point, a critical value on the critical point. And 5, you have to calculate what you call a test statistic. Here's the formula for the z, and here's the formula for the chi. There's only one formula, although we're going to study 3 different types of chi-square, but there's only one formula we'll be using. All right, this is the one for the z, this is one for the chi. That's the test statistic formula. And then we have to plot that value on the curve that we sketched before, the test statistic. And then you have to make a decision. And then you have to make a conclusion. So these are the 8 steps for the critical value approach. Then you have the p-value approach. Okay, the p-value approach starts with the pair of hypotheses. You have to calculate the test statistic and then use that test statistics to get a probability value, okay, called a significance level. Okay, and then to call a p-value, and you have to compare that p-value with what you call a significance level that is established already. 0.05 is one of the most popular ones. And then you have to decide, and then you have to conclude. So the p-value has 6 steps, which is a little simpler than the critical value approach. And the p-value approach is in Excel. You have to state a pair of hypotheses, just like the critical value and the p-value approach. You have to input your data in Excel. So no manual calculation, you put in your values in Excel and you just process the data. We'll look at some, explanations as to how this is done. There's a click of a button and you identify the p-value and you compare the p-value now with your significance level, and then you make a decision and then you conclude. Okay, so you have been introduced to the next topic, which is an assignment C called hypothesis testing. Okay.